WordPress Security Research, WordPress Request Architecture and Hooks by Alex Thomas on July 1st, 2024. Welcome to part 1 of the WordPress Security Research Beginner Series. If you haven't had a chance, please review the series introductory blog post for more details on the goal of the series and what to expect. Before diving into the security features of WordPress, it's critical to understand the underlying request architecture. WordPress is a dynamic system that processes and responds to user requests in various ways, depending on the nature of the request and the context in which it's made. By understanding this request response pattern, we can better comprehend how plugins and themes integrate into WordPress core and how to access and trigger code that may contain vulnerabilities. We hope that providing this beginner series on WordPress vulnerability research, you'll in turn take the knowledge you've gained and use it to participate in the Wordfence bug bounty program, where you can earn up to $10,000, $400 for each vulnerability reported, with the mission of helping make WordPress a more secure ecosystem. Understanding requests in WordPress. WordPress is a web application. That means at its core, it's built to handle HTTP requests and return responses. This interaction handles everything from rendering pages to performing the administrative actions in the backend. The request lifecycle. 1 is the initial request. Everything starts when the server receives an HTTP request. This could be in a simple GET request for a page or a POST request submitting form data. 2 is WordPress core loading. WordPress initializes its core, loading the necessary components to handle the request, including plugin and theme files. 3 is routing. WordPress determines what the request is trying to access, be it a post, a page, an admin panel, or an AJAX call, and routes the request accordingly. 4 is hooks and execution. This stage of the WordPress request lifecycle is where the core, along with themes and plugins, actively engage with the incoming request. WordPress core and themes predominantly uses hooks, actions, and filters to alter outputs and execute operations. These hooks are predefined points in the WordPress code where plugins and themes can intervene to modify behavior or add new functionality. 5 is the response. Finally, WordPress sends a response back to the client, which could be an HTML page, a JSON payload, or a simple status code. WordPress core request handling. When most requests hit a WordPress site, they are first intercepted by the index.php file in the web root directory. This file is the controller for all front-of-site WordPress requests. It loads the wp-blog-header PHP file, which in turn loads the wp-load.php file to initialize the WordPress environment and template. All WordPress requests result in the wp-load.php being executed in some way or another. From here, WordPress decides what to do based on the request. Request routing. Front-end requests. For front-end requests, WordPress uses the rewrite API to interpret the URL and determine which content to serve. The rewrite API transforms user-friendly URLs into query variables that WordPress understands. REST API requests. These requests are routed through index.php to the REST API handler. The REST API allows external applications to interact with your WordPress site and allows functions to execute without WordPress requiring a page reload. Admin requests. Admin requests are directed to files within the WP admin directory. By default, these requests go to the wp-admin index.php, which handles the administration dashboard. Files in the wp-admin directory load wp-load.php independently from the front of site, either directly or indirectly by including a file that then loads the wp-load.php. For example, AJAX requests are processed by the wp-admin admin ajax.php, which loads wp-load.php. Each of these entry points uses hooks to allow plugins and other themes to modify the request. Hooks and how they relate to requests. WordPress plugin architecture is largely based on its hook system. A hook, aka function hook, is simply a way to inject third-party functionality like plugin code into existing code so edits to core files do not need to be made. WordPress implements two types of hooks, actions and filters. These hooks allow WordPress plugin and theme developers to add functionality or change WordPress default behavior without editing WordPress core files. Actions. Actions are hooks that WordPress core launches at specific points during execution or when certain events occur. If you're familiar with JavaScript, WordPress actions are similar to event listeners that you might add to elements on a page. Just as you can set up a listener to run a function when a user clicks a button, WordPress actions allows you to execute custom code at certain points in the WordPress request response lifecycle, such as when a post is saved or a page is rendered. Plugins can register custom PHP functions to these hooks, which are executed when the hook is called. Here's how actions work. Definition. Actions are defined by the do action function call in the WordPress core. When the core wants to allow an action to be hooked, it calls this function. Registration. Plugins and themes register their custom functions to hooks using the add action function, specifying the hook name and the function to be called. Execution. When the do action call is reached during the WordPress's execution, all functions hooked to that action are executed in the order they were added. Here's what that looks like in action. In the WordPress core, specifically in WordPress settings.php on line 700, the init action is called do action init. In the following code example, a plugin hooks into the init action, which fires after WordPress finishes loading. So if we look at this, it's just an example action hook plugin, and they hook in the initialize action. This function checks for a custom query. So if trigger is set and trigger is set to run, then it runs the custom function, and the custom function is any action that can be triggered by this initialize hook. An example WordPress plugin demonstrating the use of the initialize action hook to check for a specific query parameter and execute custom logic when the parameter is present. So this is the custom query parameter, and that's the custom function. That's the add action function. To trigger the execution of the check custom query function, we simply need to send a request to a WordPress site with this plugin installed. If we pass a trigger get parameter, we can also trigger the execution of the run custom function seen in the example above. Since the initialize action runs on all WordPress requests, both front end and back end, the check custom query function will run on any valid request that loads WordPress. This example demonstrates how a plugin's custom function, in this case run custom function, is hooked to the initialize action, and how we can trigger this function via a simple get request. If the run custom function failed to implement authorization checks, any authenticated user could execute it. If it failed to implement nonce checks, it would be susceptible to cross-site request forgery attacks. Filters. Filters are similar to actions, but are specifically used to modify data. For example, before it is sent to the database or the browser, when WordPress is about to display a title, content, or some other piece of data, it will first pass it through a filter hook if available. Definitions. Filters are defined by the apply filters function call in the WordPress core. This function passes data through all functions hooked to a filter, allowing them to modify the data. Registration. Just like actions, filters are registered using the add filter function, which hooks a function to a specific filter. Execution. When data is passed through the apply filters call, it is filtered by all hooked functions in a sequence, each modifying the data, passing it on to the next. Here's what it looks like in action. In the WordPress core code, specifically in WP includes /post template.php on line 256 at the time of this writing, the content filter is called. In WordPress core, WP includes post template.php, content equals apply filters, the content, and then the content variable. So plugin name, content modifier, description, a simple plugin to modify content, a function to modify post content, function modify content, and then content, add custom text at the beginning of the content, custom text equals notice this content is modified by the content modifier plugin, and then it returns the custom text appended to the content. Add filter to modify the content of the posts, and we have the content and modify content. So this variable and the function. In this example, the modify content function is hooked to the content filter, which is applied to the post content before it is displayed on the screen. The function prepends a custom notice to the content of every post. Key roots in their hooks. There are a number of roots that are interesting to WordPress vulnerability researchers because they trigger certain actions that plugin and theme authors often hook into with custom functions. As we discovered in previous sections, these functions may display, modify, or remove data. They may not implement appropriate protections to prevent unauthorized users from accessing or manipulating them. So root front end triggers these hooks, template redirect, WordPress head, WordPress footer. With this authentication and authorization, none is public. WordPress admin, admin dashboard, so admin initialize, admin menu, admin footer, admin action. Generally subscriber level or higher role, exception, sending an unauthenticated request to the WordPress admin, admin ajax.php, or WP admin, admin post.php will trigger the admin initialize action. WP admin, admin ajax.php, an Ajax endpoint. WP Ajax action requires login and can be triggered by users with a subscriber level or higher role with access to the WP admin. WP admin or WP Ajax no priv action can be accessed by unauthenticated users. WP admin, admin post.php, non-public for no privilege, otherwise subscriber level or higher role. User profile update, WP admin profile.php, profile update, WP update user, personal options update, edit user profile update, generally subscriber level or higher role. Options update, update option. Authentication authorization depends because the update option action is tied to when the update option function is called by the plugin theme developer. If, for example, update option is called in a function hooked to a WP Ajax no priv action, then the required authentication authorization would be none, public. Any page load initialize, there's none. WP JSON, the REST API, there's none. Permissions can be controlled by permission. Callback, WP login.php, none. WP signup.php, multi-site registration, none. WP cron.php, none. And then the XML RPC.php, it depends on the method. So those are all the different routes. WordPress action and filter hooks relevant to vulnerability research. Now that you're familiar with routes and which hooks they trigger, let's review the most important actions and filters for vulnerability research. Init fires after WordPress has finished loading but before any headers are sent. This is an early stage in the WordPress loading process, making it a critical point for initializing plugin or theme functionalities. Admin_init triggers before any other hook when a user accesses the admin area /WP admin. Despite the name, this action can be triggered by unauthenticated users. WP_Ajax_action, a core part of the admin side Ajax functionality. It's used to handle authenticated Ajax requests. WP_Ajax_no priv action, similar to WP_Ajax_action, but specifically for handling unauthenticated Ajax requests. This hook is crucial for Ajax functionality available to public users. Admin_post and admin_post_no priv. These hooks are used for handling form submissions in the WordPress admin area for authenticated admin_post and unauthenticated admin_post_no priv users. Admin_action triggered in response to admin actions. It's a versatile hook for custom admin functionalities. It can be accessed via both GET and POST requests. Profile updates fires when a user's profile is updated. It is an important hook for executing actions post user update. WP_update_user, similar to the profile_update. This action occurs when a user's data is updated. It is crucial for managing user information. Personal options update. This hook is triggered when a user updates their own profile in the WordPress admin area. It allows developers to execute custom code when a user updates their personal settings. Edit_user_profile_update. This hook is triggered when an admin or another user with the appropriate permissions updates another user's profile. It allows developers to execute custom code during the profile update process for other users. It's almost always used with personal_options_update. Filters. The content filters the post content before it's sent to the browser. If improperly sanitized, it can lead to cross-site scripting attacks. The title. Similar to the content, this filter can be a vector for cross-site scripting if the title output is not properly escaped. User_has_cap filters a user's capabilities and can be used to alter permissions, potentially leading to privilege escalation. Authenticate filters the authentication process. If overridden or improperly extended, expanded, it can lead to authentication bypass vulnerabilities. Know that this is not an exhaustive list, and vulnerabilities can be introduced in custom plugin and theme functions that are hooked to other actions and filters. Such plugins and themes can even include standalone PHP files that do not load WordPress, which often result in vulnerabilities such as the file manager vulnerability that put hundreds of thousands of sites at risk. Examples. Let's take a look at some examples of how some of these actions might be hooked by plugin code and how a vulnerability might be introduced. Example 1, WP_Ajax_action hook in a file upload plugin. Scenario. A plugin that allows users to upload files from the front end might use the WP_Ajax_action to hook. A plugin that allows users to upload files from the front end might use the WP_Ajax_action hook to handle the upload process. The plugin registers a function to this hook that processes the file upload. Let's read through this code really quick. So there's a function, handle file upload. If file in files is set, then file equals file. The vulnerability, the function does not properly check the file extension and MIME type, MIME type. An attacker could upload a malicious PHP file as a subscriber level user. Another issue is the lack of direction traversal protection. So example of insufficient validation, it's saying that if the file size is greater than this value, then echo output. The file size is too large, and then looks like it's a function to like kill WordPress. Assume the file is moved to a directory accessible via the web. Move uploaded file, and then the file with a temp name moves it to WordPress content uploads and appends the file name. An echo file uploaded successfully. Echo no. Otherwise, if the file is less than this size, then it echoes no file uploaded. And then the WP die function add action, WP Ajax upload file, handle file upload. So the notes here say that since this is an insufficient check, and that an attacker could upload a malicious PHP file as a subscriber level user, because the file extension and the MIME type are never checked, just the size of the file. So to access this function, a post request would be made to the WP admin ajax.php with the action parameters set to upload file. So post WP admin ajax.php, the action parameter is set to upload file. Real world example. Check out this real world example of an arbitrary file upload vulnerability discovered in the WE Manage App Worker WordPress plugin that earned a $657 vulnerability. Example 2, admin_init hook in a plugin with a PHP file inclusion. Scenario, a WordPress plugin intends to allow administrators to include various PHP templates. However, it uses the admin_init hook and includes a PHP file based on a user supplied input, leading to a potential LFI vulnerability that is exploitable by a subscriber level user. So there's this function plugin template includer_init vulnerability, including a PHP file based on user input without proper validation. This could lead to a local file inclusion if an parameter manipulates the template parameter. So it says if is set and then gets template equals the template. Example of a vulnerable include statement. An attacker could potentially execute arbitrary PHP code, include path to template, and then append the template, and then append the PHP extension, and then hooking into admin_edit, add action, admin init, plugin template, includer init. As noted in the key roots in their hook section, we can access this function via a simple GET request to the WP admin endpoint. So here's the URL, example-wordpress-site.com/wordpress-admin/?page equals some_plugin_page at log_file equals the directory malicious. Check out this real world example of a local file inclusion vulnerability discovered in the master.lms WordPress plugin that earned a $937 bounty. Other examples, tracing a request to a hook. Let's trace a typical request to see where the vulnerabilities might be introduced. Front-end page load. A user visits the homepage. WordPress loads and parses the request. The template redirect action is triggered. A plugin hooks into the template redirect to add custom redirection logic, but fails to validate the URL properly, lending to an open redirect vulnerability. Admin area. A user makes a request to WP admin. The admin init action is triggered, a theme's functions.php file hooks into the admin init to add custom settings but does not check user capabilities, allowing any logged in user to change settings meant for admins only. Ajax request. A user submits a form that triggers an Ajax call to admin-ajax.php. WordPress routes the request to the appropriate handler based on the action parameter. A plugin handles the request but does not verify the nonce, making it susceptible to cross-site request forgery attacks. WordPress plugin and theme loading and request mechanics. While plugins and themes commonly hook into various WordPress actions and filters to implement their functionality, they can also directly handle requests in the parameters. Let's review how plugins and themes are loaded and how they can perform actions based on user-supplied parameters. Plugin loading. All plugins have a main PHP file and can be identified by a header comment that typically looks something like this. Plugin name, the URI, the description, version, author, license, and text domain. So you'll see a PHP file with this comment. When a WordPress plugin is activated, it's registered within the WordPress database and its main PHP file gets loaded on every subsequent request to the WordPress site. This behavior is crucial to understand because any code placed directly in the main plugin file executes during each page load, regardless of the context or the user's intention. For instance, consider a plugin with the following code in its main PHP file. So if is set get request delete and get request delete is equal to all posts, a function that deletes all posts. This code checks for a specific get parameter and triggers the delete all posts functions accordingly. Without proper validation and security checks, this code would introduce a vulnerability that allows an attacker to delete all posts without any authentication. Without proper validation and security, this code would introduce a vulnerability that allows an attacker to delete all posts without any authentication. Theme loading. WordPress themes control the presentation and layout of content on a website. Unlike plugins, which often add specific functionalities, themes primarily determine the visual aspects and user experience. However, while not as common as plugins, our experience shows that themes do implement user-controllable functionality on occasion. WordPress uses a template hierarchy to decide which file in the theme should be used to display a certain type of content. For example, single.php is used to display single individual posts for all post types. Page.php is used for individual static pages. Archive.php is used to display a list of posts grouped by category, tag date, author, or custom taxonomy. It provides a way to present archive content. This is just a WordPress template hierarchy visualization. Each of these template files can contain PHP code and HTML to render the website's content. Like plugins, the PHP code within these theme files is executed on each relevant page load. As mentioned earlier, themes may also directly handle user requests. This can happen in various theme template files or even in the functions.php file, which acts like a plugin and is automatically loaded by WordPress. For example, a theme might include code in functions.php to handle custom query parameters for theme-specific functionalities. So if the get request of theme action is set, then you can perform some specific theme action based on the query parameter. Similar to the previous example that allows attackers to delete all posts, if the condition is met in the above example and appropriate validation and security checks are not in place, an attacker could leverage this code to perform an action that may not have been intended for unauthenticated or lower level users. Conclusion and next steps. In part 1 of this beginner series on WordPress, vulnerability research, we delved into the WordPress request and response mechanism, uncovering the important role of hooks, both actions and filters, and how plugins and themes integrate with WordPress core. We examined the common hooks and their related requests, providing examples of their usage and how they can be triggered. Understanding the request architecture in WordPress is a fundamental step in identifying and testing the exploitation of potential vulnerabilities. It enables us to discern how plugins and themes interact with the core system and how their functions, accessible through HTTP requests, might present security risks. This knowledge is vital for testing and asserting these functions for vulnerabilities in practical scenarios. In part 2 of this series, we will delve deeper into each type of request and dissect the common security issues associated with them. A particular focus will be on WordPress Security API, examining its effective use and common misuses by plugin and theme authors. We encourage you to get started with the local WordPress installation and apply this knowledge with existing plugins and themes. Stay tuned for the next part in our beginner vulnerability research series, and don't forget to register as a researcher for our bug bounty program and join our Discord to engage with the Wordfence threat intelligence team and other security researchers.